Okay, hi guys, and welcome to another video. So this is the non-parametric methods, and we're doing part 2, which is called the rank sum test. Now this is a continuation of the first video. So what actually happens here is we're testing two populations. Now let's read the question to actually understand what we need to do. We're still going to follow the 5 steps, and I'm going to explain what's the difference. So they say the psychologists expand their study by comparing South Africans to Europeans. They subject 10 Europeans to this 10 Europeans to the same test and obtain the following results. So for the Europeans, we have 4.2, 4.8, 4.9, 5.3, 5.9, 6.0, 6.2, 6.2, 6.3, and 6.5. Now they say use the rank sum test to determine whether the mean reaction time of South Africans is shorter than that of the Europeans. So you see I underlined the word shorter here to show that that is a left-sided hypothesis. That is the key word which actually tells us. Now, there is a mistake in this question because they said the mean instead of the median. So for the rank sum test, we don't use the mean, but we use the median. Mean is for starting at 3, starting at 4, and starting at 6. No, not 76, 73 and 74. So they say formulate the null and alternative hypothesis. Formulate the null and alternative hypothesis. So they repeated the word. You see there's a mistake in this question. Show all your calculations and fully explain any conclusions. Use the significance level of alpha equal 10%. So we're using alpha equal 10%. So the first step is to state the null and alternative hypothesis. And then here I wrote them down. This is the null hypothesis H naught. So N1 equals to N2. Median 1 equals median 2. The alternative is that median 1 is less than median 2 because they said the population for South Africa is less than that of the European. So they will give you two populations all the time. In most cases, or in always the time, the first sample is going to be a smaller one and the second one is going to be a bigger one. As you can see, here's 1, 2, 3, 4, 5, 6, 7, and here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 7, this is 10. In most cases, it's going to be like that. The first one is going to be bigger than the second one. Alright, cool. Now, step number 2, specify the significance level and the test statistic. So the significance level, as I already wrote it here, is alpha equals 0.10. Because you're dealing with left-sided, you don't have to divide this by 2 because you only do that when you have two-sided hypothesis. And then the test statistic that you're going to use is called the W test statistic, which is equal to the sum of so I'm going to write this down here, sum of the rankings sum of the rankings ri sum of the rankings for the first sample. So this one here shows that is the first sample, and then you sum the first sample rankings, then you're going to minus n1 into n1 plus 1 over 2. That is the formula that we're going to use for the test statistic of the Wilcoxon Rank Sum Test, for the rank sum test, right? So now, before we get to this, we need to rank our values. Now, we say we're calculating the sum of rankings for the first sample, but when we do the rankings, we do them all at the same time. Like I said, this one is going to be an easier one because these are in order. So it's going to be easier. So in the test, or in the quiz, if maybe it's going to be there in the quiz, but I don't think it's going to be in the quiz. In the test or in the exam, you're going to find that these numbers are not actually in order, like they are mixed up. Maybe the first one was 4.1 followed by 5.5 before 2.5 and then 6.8 then 4.1. Here the same here as well. Maybe they start with 6.0, 6.3, 4.8, 5.3, 4.2, and so on and so on. But you just have to see them like that. You have to see them like that. So now, um, this is how you do the rankings. The first number, you do the rankings at the same time. You don't rank this one first and then this one after. You do the rankings at the same time. So this number here, the first one, 2.5, since it's the smallest here and in here as well, is going to be ranking number 1. 3.8 will be ranking number 2, and then 4.1 will be ranking number 3. Then 4.2 becomes ranking number 4. Before it comes before 4.9. So this is going to be ranking number 4. 4.8 is going to be ranking number 5. And then 4.9 comes this side and this side as well. So we have two 4.9. Now we can say this is ranking number 6, this is ranking number 7, because this one is going to feel unfair. It's going to feel like it's unfair that this is 6, this is 7, whereas they are equal in size. So what you do is you take the sum of the two rankings and you divide them by 2. So you're going to take some ranking number 6 and ranking number 7. Let's say this is 6, this is 7, or if this is 6, this is 7. It doesn't matter. So you take the ranking number 6 plus ranking number 7, not the numbers, not the values, the rankings. So ranking for this will be ranking number 6, and for this will be number 7. So you're going to say 6 plus 7, and then you divide by 2 if it's two values. And then if maybe it's 49, 4.9, 4.9, there's another 4.9, then you're going to say ranking number 6 plus ranking number 7 plus ranking number 8 divide by 3. So you're going to add them all together. In this case, my calculator doesn't want to open. All right, it's cool. You're going to say ranking number 6 plus ranking number 7 divided by 2. So in this case, it's going to be 6.5. That's going to be our answer. 6.5 is going to be ranking for this, and it's going to be ranking for this as well. 6.5. 6.5 will be the ranking for these two. My calculator doesn't want to open again. Okay, cool. It's fine. So ranking 6.5, 6.5 as well, then followed by 5.2. 5.2 will be ranking number 8, because we already have 1, 2, 3, 4, 5, 6, 7 rankings. Even though these two are sharing a ranking, but remember it was originally ranking number 6 and ranking number 7. So this one's become ranking number 8. And then this one is going to become now ranking number 9. This one is going to become ranking number 10, 5.5, ranking number 10. And then this one is going to become 5.9 is going to become ranking number 11. This will be ranking number 12. And then this two, they have the same number, so it's going to be ranking number 13 plus 14 divided by 2, which is going to be equals to 14.5. Yo, look at how many calculators have opened now. Okay, let me just close this other ones. So yeah, how we got those rankings, it was 6 plus 7 divided by 2, then it was 6.5 for those two rankings there. So now we're going to do the same for this ones here. It's ranking number 13 and number 14, so it's going to be 13 plus 14 divided by 2, which is going to give us 13.5 for both of them. So it's going to be 13.5 for this one, 13.5, and then it's going to be 13.5 for this one as well, 13.5, 13.5. And then 6.3 is going to become ranking number, it's 13, it's 14, then this becomes 15, ranking number 15. 6.5 becomes ranking number 16, and then we have 6.8 as ranking number 17. That is the last ranking, number 17. That's the last ranking. And if your rankings are correct, the last ranking should be equal to the two sample sizes combined. Remember, this was 7, 1, 2, 3, 4, 5, 6, 7, and this was 10. What is 10 plus 7? 17. So it means your rankings are correct. Now we can go and calculate the test statistic. Our test statistic is equals to, they said, the sum of the rankings for the first sample. So you're only going to add the sum of the rankings for sample 1, not this one. So you're only going to add the sum of rankings for sample 1. So what you're going to do is you're going to say 1 plus 2 plus 3 plus 6.5 plus 8 plus 10 plus 17 plus 17, and you're going to get 47.5. So this part of the equation is going to be 47.5. 47.5 minus sample size number 1 is 7. So you're going to say minus 7 into 7 plus 1 close bracket over 2. This is your test statistic. Now the test statistic is going to be now equal to, let me just say this, 47.5 minus minus 7 into 7 plus 1 over 2, and the final answer is 19.5. 19.5. 19.5. 19.5. That is your test statistic. Now that we got the test statistic, we need the critical value. We need to calculate the critical values as well. Now, the critical values that we're going to have is going to be two critical values. The first one is going to be W of N1, N1, comma, N2. This is the comma here, comma, N2, and uh, N1, N2, and alpha, and this will be equal to W of what is N1? N1 is 7. What is N2? N2 is 10. And what is the alpha? Alpha is 0 0.10. 0 0 oh, my mouse. 0 0.10. 0 0.10 over there. Now this is going to be equal to, so you're going to go to the table. So this is the table that you're going to use, the critical values for the rank sum test. Now this table is where it gets a little bit tricky for most students, because they started with the N2. You see here they said N2 before N1. Now this is how you're going to look at it. Like, the first thing to look at is the second sample size. In our example, the second sample size is 10 Europeans. So now there is different tables. So this is where N2 is 3, this is where N2 is 4, this is where N2 is 5, 6, 7, and so on. So you look for where N2 is equals to 10. In this case, this is where N2 is equals to 10. So meaning that you're going to focus on this part of your rank sum test table. And then after this, you go into take the second sample. The second sample was 7. So here is 7. So meaning that you're going to look at where 10 and 7 are. So this is the second sample, this is the first sample. Then you look for your test your significance level, your alpha. In this case, alpha is 0.10, which is this one. You go down, and this is your critical value, your first critical value. So this is equals to 21. Now that's your first critical value, like I say. And then the second critical value, for the second critical value, what you're going to say is, you're going to say n1 multiplied by n2 minus W of N1 N2 and alpha. So that is equal to what is N1? N1 is equal to 7. So you're going to say 7 multiplied by 10 minus 21. So 21 is W of N1, N2, and alpha. Remember, we already got it, minus 21. And that is going to be equal to 7 by 10 is 70. 70 minus 21, which is equal to 49. Now, from here, you need to state the decision rule. So, remember, when you state the decision rule, okay, let me just move this a little bit. Just move it a little bit. Remember, when you state the decision rule, what do? You're going to say reject or do not reject. But remember, the same thing we did with the first one. Let me just copy this thing here and take it up there. Copy, and then let me move this here and say paste. So this is the guideline. This is not the actual thing you're gonna write, but it's your guideline. And then I'm just going to edit it, because we're dealing with two populations. I'm just gonna edit it. And say N1 here, N2 here, 1 here, 2 here, 1 here, and 2 here. Now, because we're dealing with the left-sided hypothesis, we're going to reject if not B but if W. So here we're going to be dealing with W. If W is less than the small critical value, or because of this is the case, if W is less than the smaller critical value. So let me just edit for everything and say W instead of B. B is for one population. So W is, yeah, that's the guideline. Now we're going to write it we're going to write it we're going to write it statistically in a correct formal way. So we're going to say reject this. We're stating the decision rule now. We're going to say reject the null hypothesis if, in this case we're going to reject if what, if W, which is our test statistic, is less or equal to uh is less or equal to W of n1 comma n2 and alpha because it's just left sided, so it's going to be one like this. It's going to be one like this. And then in this case you're going to ask yourself, is W 19.5 less than W of because you say if it's smaller than the small critical value, if it's less than the small critical value, and this is the small critical value, remember. So is this less than this? Yes, it is less than this. This is less than this. So it means in this case you're going to reject HO. Actually you're actually going to let me just copy this and then come here and say paste. So you're going to reject the null hypothesis. You're going to reject the null hypothesis. In this case, it's not going to be an if, it's a statement. Reject the null hypothesis, because you can see that the value of W is less than 21. So if it's less than 21, you do reject the null hypothesis, and then you make you draw a conclusion. The conclusion you're going to draw is there. I'm going to say there is enough evidence to say that South South Africans have less reaction time than Europeans. Remember, that's what we're testing here. If South Africans have less than the Europeans, the reaction time. So since we reject the null hypothesis, it means we're not taking the null hypothesis. The alternative is the one that stands out. So we're going to say there is enough evidence to say that South Africans have less reaction time than Europeans. So now the same thing that you did, if because it's less than, you're gonna do if it was greater than. If it was greater than, you must do